Okay. Good morning, everybody. It's great to be here with everybody in person. A lot of great conversations. So I want to tell you about the State of the Union. And if you've been hanging around, as I have, talking to people, seen the talks go by, you're aware that the State of the Union is strong. RISC-V is doing really well. We have billions of cores shipping. And we're now seeing the highest end designs emerging. Some of these have been works in progress for quite a few years, and now we're starting to see that appear. And another very important thing I want to touch on at the end is profiles, which is how we're going to be guiding the RISC-V ISA roadmap for those high-end designs in future years. Before I dive into all that, and also actually to structure this talk, I want to start out really by giving you a public service announcement. So this is not marketing spin. This is just, you better understand this. It's really important that you get this. RISC-V is inevitable. RISC-V is going to have the best processors, and RISC-V is going to have the best ecosystem. So reinforcing what Krste said yesterday. So today I want to explain why this is it's not a wish. It's really a public service announcement. This is what's happening. This is what's going to happen. So you should plan your future computing endeavors around these facts, right? This is what's going to be happening. So why do I think RISC-V is inevitable? Well, it's instructive to go look at networking, which is actually more like the thing we're doing here in RISC-V. There used to be a lot of competing proprietary standards in networks. You know, DECnet, Token Ring, AppleTalk, FDDI, all these. And they've all been replaced by Ethernet, a single open standard anybody can use. Now, the reason RISC-V is inevitable, I wish I could say it's because it's such a wonderful instruction set. I mean, I'm a bit biased, and I do think it's a wonderful instruction set. But the real reason is industry wants the open standard ISA business model. So that's why RISC-V is inevitable. So all the engineers out there, the technical stuff is amazing, but it's really this change in the business model is why RISC-V is inevitable. And just to think about this, once you move to a high-quality open standard, you never go back to sole source proprietary standards, okay? So moving to RISC-V is really a one-way street. Everybody's gathering in the RISC-V community as they finally make that leap over, and this community is just getting bigger and bigger, covering more and more bases, and that's why it's inevitable. It's just building on that strength. And again, it's about the business model change of being an open standard as opposed to sole source proprietary standard. Now, RISC-V happens, it will also have the best processors, and there's a couple of major contributors to why that is going to be true, or is already true. We're starting to see, now that those high-end designs are being completed, fabricated, mapped to the newest technology, we're seeing that there does seem to be inherent ISA advantages to RISC-V over the others. It's still early days in quantifying this, but I think you're going to start to seeing a lot of very interesting comparisons coming out, showing you that RISC-V allows you to build the most efficient cores at any design point. Whether that's you're going after highest performance, best energy efficiency, smallest area. The other factor is, as well as the inherent technical advantage, there's many vendors competing for those sockets, the various design wins. So competition drives innovation. As you have all these vendors chasing these sockets, it's not just one vendor, you have many. And the second part about being the best processor, those vendors aren't all competing for the same kinds of socket. There are specialized vendors going after certain markets. So they focus their energy on servicing the needs of this smaller niche in a way that a large single vendor wouldn't be able to. Right? And so this is why you're going to have the best processors in RISC-V land. And just to throw out the numbers, to me this is kind of incredible as I sat down and tried to make a list of all the companies who are building out-of-order superscalar vector processors. There's a long list. So all these folks, you know, they've hired lots of outstanding engineers, they're all busy working away designs, and they're going to be competing. And this is part of the open standard opens us up to competition, and that competition inspires innovation, right? So these guys are going to be building the best processors out there. Now, one thing we've been, at SciFi, we've been sort of looking at this and trying to understand, because our customers ask us, how come the cores are so much better than the other cores, the competing cores? So we've been trying to understand that ourselves. We obviously have a fantastic engineering team, but there does seem to be an advantage coming from the ISA. So some of the things, this is still early days, like I said, I wouldn't be able to get an academic paper published with this, but having a simpler base and modular extensions, we seem to get much better PPA, equivalent performance levels. Now, some of the deep technical reasons, reduced dynamic code size, having a compare and branch instruction, no complex instructions. Our instructions only read two integers, two-integer reads at one point. Clean sheet design, there's a lot of stuff that just doesn't have to be there. And we did design it for extensibility while keeping that standard software stack. Now, one particular thing I'll point out is variable length instructions. So I get a lot of negative feedback from designers who are embarking on their RISC-V mission and saying, why did you have variable length instructions? It ruins my design knowledge. And usually the way I think about this, those engineers are the same ones who probably thought in order of VLIW designs were a good thing for high performance machines. And people tend to confuse simplicity with efficiency. So efficient things are not usually simple. Efficiency usually needs complexity, right? Making something efficient adds complexity. The variable length thing adds a lot of efficiency in terms of static dynamic code, right? So that's why we did it. And as you'll see in the future, as we start adding more instructions to the ISA, having that variable length ISA is going to be very important to keep growing, improving in performance. So another big deal is the ISA was designed with a community of experts. It wasn't just one group of engineers or architects at one company. It was the whole community, including academics, and everybody working together to improve the ISA. And as we're seeing, there's no limits in the levels of performance or application domains you can target with RISC-V. And it's very quickly, in the space of a couple years, 2-3 years, you're going to see designs that surpass all other architectures in RISC-V. Now, it's not only about the high-end application cores. Those are, the most exciting. They're the kind of movie stars of the processor space, these high-end application cores. But there's all the other cores that do all the work. And so, paraphrasing, all your cores belong to us, right? The great thing about RISC-V, you get to end SoC ISA balkanization. So if you look at an SoC, apart from the apps core, you have all these other supporting cores that have dozens of different ISAs. And most of those are bad ISAs, and they're poorly supported in software. So many folks, I've talked to a few of you here over the last few days, are sort of echoing this. Everybody wants to move all their cores on the SoC, all the other cores, to RISC-V-based cores too. So things like graphics, image, AI/ML, radio, audio, DSP, security processors, power management processors, all those other random cores you have on the SoC, you want to move everything to RISC-V. And a bunch of companies are already on that path. They already started this process of shipping everything else to RISC-V. And so the advantage here is you have not just a uniform software stack, but you have a high-quality software stack because instead of fragmenting that software support across all these different ISAs for all these different engines, you get to share a common tool chain, debug, trace, all those other facilities. And that's very powerful. So the final point is RISC-V is going to have the best ecosystem. Now, this may be hard to believe right now. Everybody's worried about, how do we fill in the gaps and everything. But one thing to say is the largest number of players, as these companies and everybody, almost everybody's moving to RISC-V. That's the force that's going to drive, develop out the ecosystem, as well as all the cores in the system becoming RISC-V. The other big factor is software wants to run on the best hardware. So if you have the most energy efficient core, if your earbuds have twice the battery life of your competitor's earbuds, that's kind of important, right? And those are the kinds of gains I think we'll be seeing. And so software likes to run on the best hardware. So the best hardware will be the best processors. The best processors will be RISC-V because RISC-V is inevitable. So software is going to want to run on that hardware. And we're starting to see that. I'm very excited for the next keynote talking about Android on RISC-V as one example. So the hardware and software have been co-evolving rapidly. And in previous times when I give a talk like this, people would say, well, RISC-V is good for microcontrollers, good for embedded, good for IoT, but it'll never be up in the data center class. And I had to bite my lip a little because I was aware of all these design teams working on those high-end systems, right? Now we're starting to see that appearing. And it's obvious to any architect. There's no reason why RISC-V couldn't be as fast or faster than any of the other ICs out there. It's just a question of time, energy, motivation, finding the right socket to do that. So that's happening now, and people are seeing this. So this year is where you see that, hopefully, that illusion that RISC-V is only for some subset of the space disappearing. RISC-V is going to be everywhere, doing everything, and doing it better than the current architectures. That's what's happening, right? And that's really bearing fruit now. And this builds on itself. It's a positive feedback. As people see that, more people come in. And like I said, it's a one-way street. Once you go from proprietary sole source to open standard, you don't go back, right? Once you have enough to make that move, and this will just build this group stronger and stronger, this whole community. So now one important thing in the software ecosystem, people, like fragmentation is a word that's brought up a lot. And frankly, it's kind of this bogeyman that comes up all the time. I think actual, in the field, experience with it is it's much less of a real issue than people claimed it to be. And also for RISC-V, I think the important thing is sometimes there'll be some slight divergence as draft standards are being produced and there wasn't a feature, so people did something different. But what you see is all those, if that does happen, those vendors do tend to come back. They want to come back to be on the common standard. So there's very strong forces that are avoiding companies from wanting to fragment, the major one being the software ecosystem. You need to be running standard software if you're going to be successful, because you cannot build the whole software ecosystem yourself. So that's one powerful force. The other powerful force is customers insist on things being a standard. The big reason they're moving to RISC-V again is it's an open standard, and that means there's competition, and that's good for the consumers of RISC-V technology. So to help the software ecosystem, profiles, you've heard a lot about that, and this is really for the rich operating system environments, things like Linux and other rich operating systems, to help guide the tool chains there to say, you can rely on much less diversity in those kinds of cores. So we've been producing these profiles, and the first few of those, RVA20, RVA22, those are now frozen. We managed to reach agreement not only on the contents of the profiles, but also the structure of those profiles, how we're going to organize them, and how we're going to produce them. And they're going to provide a very simple, unified ISA view of the ISA roadmap for those rich OS systems. So in the profiles, if you go look, there's a document open. You can go see this on GitHub, the current 0.8 version of the spec. In those profiles, what you see, there are many mandates that said, you must have this feature laid out. And it's taking very great care to strap down, bolt down, all the various bits of, excuse me, casual optionality that we kind of accidentally put in the privilege spec, I guess. So there's a lot of flexibility in RISC-V ISA design, which is useful in other domains, but in this domain, we really want to simplify software's life. So in the profiles, we've gone through and made many mandates and nailed down, you have to do all these things to be compliant with this profile. There are still a few options, and there will always be options. They're needed for things like cryptography, where different geo-regions have different standards, for example. There's also, this is a roadmap, so we have to bring the whole community with us. So over time, we'll be adding newer features as options in one generation of the profile, and then that will eventually move into mandatory. So the idea is over time, this mandatory set is going to keep growing and growing and growing over time as we add more capability to RISC-V. But remember, the goal here is to simplify the life of the software ecosystem by having many fewer options. So one other thing we realized in doing this was RISC-V is developing fast. We have an annual cadence is the plan for these profiles, at least for the next few years, because there's so much work going on. There's so many new features being added. But that's kind of hard for big ecosystems to track. And so what we're doing with the profiles is designating certain ones of those, so roughly, let's say every 3 years or so, to be a major release. And a major release is intended to capture substantial improvement in features over the previous major release and something that can be considered like a long-term stable point to support in the software ecosystem. And in effect, we had this de facto standard from way back, I remember at the MIT workshop in 2016, where we were talking to the distros and basically came to this agreement that RV64GC shall be the ISA that is used by the distros, because they, at that time, didn't have hardware. So they were building complete distributions using QEMU, right? And so they didn't want to do two different versions, right? So we told them that, and that became the de facto standard. And actually, there was no fragment, there's actually no options there at all. The only option that we captured in RVA20 was whether you had hardware performance counters or not, right? So in fact, the distros are focused on that one ISA profile, and we formalize that as RVA20, and that's effectively been our first major release, from 2016 until now. What we decided was RVA23 will be our next major release. And so that'll be next year. There's a bunch of important new features we want to make sure get added in there to be standard and used by the platform. And we do view this as particularly critical because this is the point at which we see these very large, rich software ecosystems shifting from experimental development mode into production mode on RISC-V. And so a lot of them are going to be targeting RVA23 as the thing they go after that's going to be quite long-lived. Some of the software developers warn me that once they do this, they're not probably going to change for 10 years or more over the thing they put in default. Partly, it's their cost, but also we'll start having a lot of systems deployed in the field, and they stay in the field for multiple years. You have to support those devices, right? So RVA23 coming next year, that's going to be the second major release. And as I said, the intervening years, we'll keep doing the profiles because we have to bring the new features on board. We have to get the tool chains ready. We have to develop the features. Also, end users may be able to use an older OS, but for that one application they care about, use some new extension that's available in an intermediate profile, right? So we're going to keep doing the intermediate ones to drive innovation and to describe the roadmap for folks. But every few years, we're going to do these major releases, which will be a major uptick in the set of features supported. OK, so I have a few minutes left, and I'm going to finish early, like I like to do. So just to re-emphasize again, RISC-V, I'm just going to wrap this up with RISC-V is inevitable. Just believe that that's a fact. I'm just telling you that as a service to the community. And the reason is industry wants this business model. That's very clear. Right? It's going to have the best processors. Maybe this wasn't as clear to folks, but now we're seeing those proof points from various vendors. As they do the comparisons, as those designs reach maturity, as they get mapped down, people are seeing the highest end leading performance. Also, this factor of many vendors. And so there's niches that can be addressed by different vendors going after different targets. So you don't have one company trying to sell you a Toyota Camry when you want a bulldozer, right? Or some company trying to sell you a bulldozer when you want a Toyota Camry, right? Different vendors can hit those different needs more precisely. And that's why there's going to be room for a very large ecosystem of core providers. We already have more core providers than any ISA in history. And part of that is because all the cores are going to be RISC-V. So we're going to need vendors providing specialized cores for radio DSP, for security management, for power management, for rad-hard processing in space. All those niches can be much better served by a focused effort. They maybe come from one vendor or maybe a product line in a bigger vendor, right? But that's another reason RISC-V is going to have the best processors. And finally, because of these two things, it will lead to having the best ecosystem. Largest number of players working with RISC-V. Everything becomes RISC-V. And software just wants to run on the best processors available, and those will be RISC-V processors. OK, thanks. That's it.